Now. Okay, so hello everybody. My name is Michael. I was a Web 14 student, and I'm currently PMing for Web 17 as well as a part-time 4 cohort. And I've been learning GraphQL for a little bit of like probably like a month and a half now, I'd say, on and off. And I built a few projects with it. So today I want to share some of what I've learned and also walk everybody through building a simple like note-taking API. So if you did the Land of Notes project, this is very similar to that. So this right here is called a GraphQL playground. So you can compare this to like a Postman, which is something we use here at Lambda, and you'll see that we're eventually going to build this out where we can query for notes. We'll get into what a query is later. And then if I open up the schema tab, which again we'll talk about later, you'll see that we have the ability to create, update, delete notes, and all this other stuff. So let's get into like what GraphQL is, like a high level overview. So I'll head over to the docs, and you'll see right here that one of the big things is predictable results. So if I only want to return name, I can get just that data, and then I can add fields on as I wish. One of the benefits of this is that, let's say you're writing the front end code in React, and you only need the names of all your heroes. Well, I can write a query for just the names and nothing else. Whereas in like a typical REST API, I might just display the names, but they'll return like age and height and all this extra stuff that we don't need. So that takes care of like overfetching data. Another big thing about GraphQL is that it's strongly typed. So every field in your API has a corresponding type. So if I open up that playground again, you can see that I'm expecting like a string for a title or an ID for an ID field. And again, we'll get into that again a bit more. And then another big thing is that all GraphQL is a specification. So what that means is that if I open this up and I look at, it's basically GraphQL is one long document that tells you everything you need to know about GraphQL. And what this means for us is that we can implement it in any programming language. So this is a great resource for learning GraphQL, and you'll see here that they have tutorials for like a number of languages. You have Node, Python, Scala. You can implement it everywhere you like, which is also really helpful. So that's a little bit about like what GraphQL is. Let's talk about why you might want to learn GraphQL in general. So there's a lot of companies migrating to GraphQL. You can read about PayPal has had success with it, Airbnb. So there's plenty of articles you can look through. NPM also put GraphQL in their predictions for what you should learn in 2019. So there's a good chance that becoming well-versed in GraphQL will be a highly marketable skill in the near future. And also, it just makes your life as a developer easier. I really like this picture. A company moved to GraphQL, and they were able to delete thousands of lines of code. So it really just goes to show that once you get the fundamentals down, you can really produce a lot simpler applications. So I talked about the what and the why, and I showed what we're going to end up building. So let's actually start building that. I'm going to do everything from scratch. Let's hope for no errors. So let me create a new terminal window. So I'm just going to create a folder for these files. So I'll just call it brown bag. Let's go in there. And with any package, it all starts with an empty package.json file. Okay, so we see we have that here. And we're going to need a few packages. So actually, just a couple. So we need GraphQL Yoga, and I'll talk about what these are. Prisma client lib and GraphQL for a peer dependency. So while that's installing. So remember I said we can use GraphQL in any implementation. We're going to be using GraphQL Yoga. It's a very lightweight GraphQL server. It makes it really easy to get started, and it's also one of the more popular choices. So that's what I learned how to use. So that's what we use here, and I think it's a great starting point. But there's like Apollo server. There's a numerous amounts of GraphQL servers you can use. So you can explore those. And then Prisma client lib is something that we'll use later on, but I just actually have to install it now. And before we build a note-taking API, I'm just going to build like a very bare bones simple server just to go over some core concepts and also to show you how it works. So I'm just going to make a source directory. And then we're just gonna need an index file in that source directory. Okay, let's open that up. Okay, so we have our dependencies, and let's get into building a simple server. So let me make this a bit bigger. Okay. All right, so you saw how we installed GraphQL Yoga, and all we need from GraphQL Yoga is an instance of the GraphQL server. And we'll get into why we need this in a second, but let's just bring that in. Okay, and then the two parts of you need of the GraphQL server are your type definitions and your resolvers. So I'm going to build out a simple type and resolver, and then we'll talk about what's going on and explain some of the concepts. So let me just write this out first, and then we'll go from there. So I'm gonna have a query type, a query for info. All right, so let's go over what we have here. So as I said, for any GraphQL server, you're gonna need your type definitions and your resolvers. So let's make a comment so we can talk about this. So in my type definitions, you notice I have a type query, and GraphQL has three built-in types. Those are query, mutation, and subscription. So query is basically like the R of CRUD. So anytime you're reading data in any form. So in my playground here that we're going to build, you'll see that I'm querying for all my notes, and that's the only one we have here, but that's just a quick example. And then the next part of this is mutations. So let me go back to this. So mutation is anytime we're like modifying data or creating it. So I have a create note mutation, update, delete. So that's the rest of our CRUD. So those are what query mutations are. And the last one is a subscription. We're not going to get into these because they're a bit more advanced, but basically they allow for real-time updates. So if I had this project working and I created a note in the browser, I would be able to see that new note without refreshing the page, and that's kind of what subscriptions allow for. Okay, so right here we have our three root types, and then we have this info field. So on our types we have fields. So I have a query type with one root field of info. And I'm saying, hey, if I query for info, I'm expecting to return a string. So this is the next core concept that I talked about earlier, the type system. So there's 5 built-in scalar types. We have string, Boolean, float, integer, and ID. So I'm just telling my GraphQL server, if I query for info, I'm expecting you to return a string. And the last part of this is this exclamation point. All that means is that this is required. So if I query for this, I'm required to return a string. All right, and then that's all well and good, but how does GraphQL know what data to return for this field, right? So that's where resolvers come into play. So you can think of building a server in this way. You define your fields on your type, and then you implement the resolvers for those fields. And the resolver is basically a function that returns the data for that field. So to demonstrate that, you see that on query, which is our type, we have one field, info, and we have a function that's going to return us a string. So that's the data for this field. So that is a simple GraphQL server. Let's just make sure that this is working correctly. So to start our server, we just need a new instance of this GraphQL server. And then we pass in type definitions as well as our resolvers. Okay. And then the last part of this is just starting the server. So server.start. And by default, it'll run on port 4000. So I'm just going to say running on HTTP localhost 4000. And before I start this, let me kill this demo one just so we don't get an error. Okay. All right, so let me go back to my terminal. I can minify that. And then I'm just going to run this index file. Oops. Oh, this is not a. All right, so now we're running on this port. Let's open up our playground and let's see what we're working with. So let me get rid of this. So now, as I said, our schema is basically our available API operations. So what we're allowed to do with our server. So if you see our schema, right now, all we have is one type of query, and we can query for info. So that's all I can do in this playground, and it's telling me what data I'm expecting if I query for info, as we define in our file. So if I write a query for info, I'm going to expect a string. Let's run this query, and we'll see that we get hello. So that's working. So that's a demonstration of a basic GraphQL server. Let's actually get into building out our note-taking API. So let me kill this, and let's get to it. So I'm going to go back to my files, and so real quick, you can kind of just see that this is like a small contrived example, right? We have like one query, one resolver. But in a real project, I'm likely to have maybe like 5 different types and maybe like 24 resolvers. So you can quickly see how this file can become very large very quickly. So we're just going to abstract these implementation details to their own file to really organize our code. We'll put our type definitions in a schema file. So we'll call it schema.graphql. And before I forget, let's just make sure that our server knows about that. So we're going to point our type definitions to this file we created. So a schema.graphql. And we'll build out our resolvers in their own folder. So we'll have a resolvers folder. And we're going to need 2 files there. So if you see our demo application, we have, the schema got updated. But essentially, we're going to need to create notes. So we need to query for note. I'm sorry. We need to be able to create notes, and that's a mutation. And we're also going to be able to read all of our notes, which is a query. So we're going to need 2 files in here. And we'll get to building these out in a second. I just want to have a bit of our file structure ready. And these resolvers, we'll import them later. But for now, we can just leave this file like this. Okay, so in order to make implementing our resolvers a lot easier, we're going to be using Prisma, which is the other part of this talk. And so Prisma is going to allow us to implement our resolvers. And as you'll see in a second, Prisma is going to generate a file for us, which will have a bunch of CRUD operations already built for us. So that might sound a little abstract, but let's actually just see what it looks like, and then we'll better explain the concepts. So to get started with Prisma, let's first talk about what Prisma is. It's just a layer that sits on top of your database. And like I said, it just provides CRUD operations out of the box for you. You don't have to do anything except give it types, which we'll see. So we don't have to get too much into what Prisma is. We just need like a high-level overview for this talk. So to configure Prisma, we need to do 2 things. We need a Prisma folder, and we need to give it 2 files. And let's talk about what these files are. So we need a data model.prisma and a prisma.yml. And I'll talk about these in a second. Okay, so a YML file right here, this is our configuration file. So it's kind of like a template for our API. And so what goes in here rarely changes. So I'm just going to take it from our finished application and then explain what's going on. But essentially, this will be very similar every single time. So it's okay to do something like this. So when I deploy my Prisma server in a second, it's going to need an endpoint. It's going to give us an endpoint. So that's this endpoint field. We need to point to our data model file so it knows what to generate in that file that I was talking about. And then this just tells us where to put it. So it's going to put it in our source directory. So that's what's going on in this file. And then the last part of this is our data model, right? So the data model is basically where we contain our application models. So again, just seeing this might make more sense. So here we're building a note-taking API, right? So I'm going to need a type of note, and I need to tell Prisma what it looks like. So I'm going to say type note. And then, so to modify a note, I need to know which note it is. So I need to have an ID field. And I'm going to use a directive to tell Prisma, hey, I want no 2 IDs can have the same ID. So I want them all to be globally unique. And then In addition to an ID field, we'll have a title of our note, and we'll make that a string. And then the content of the note itself, which is also a string. So this is all we need in our data model. And then we're gonna start Prisma up, and then you'll see what Prisma does with this data model file. So let me save this. Let's go back to our terminal. And I have the Prisma CLI because I globally installed it. So if you, after this, say, hey, maybe I want to learn Prisma and GraphQL, you'll have to do that. And most tutorials will tell you that, so it's not a problem. Basically, that allows me to run commands with just typing Prisma. So let's cd into this Prisma folder. So we'll go into source and then into Prisma. And now you see I'm in the right folder. And I need to run two things. And the first one is Prisma deploy. So let's see what happens when I run this. Okay, so it's giving me options. So as I said, Prisma is a database layer that's that we're gonna use to configure our server. And it's giving me a few options. I can use an existing database. So you can bring your database and put Prisma on top of it. You can create a new one. This is one that I built myself. And then most of the time, especially when you're learning and even for production apps, you just start off with a demo server. So I click demo server and it's telling me where I want to host it. I'm just gonna pick US, it's fine. A name for the service, I just call it brown bag. Stage, we're in the dev stage. Okay, so what has Prisma done? Well, it's given us this endpoint. So if I go into my YML file, I can see that this endpoint is here. And let's actually see what this gives us. So it gives us a playground with a bunch of stuff that we can do now. And one more part of this being hosted is if I go to my Prisma console and we go to that brown bag one we just created, it shows us all of the data in our API. So right now we don't have any notes, but when we have notes, we'll be able to see them all here and do some cool things with them. Okay, so let's get back to our file. Okay, so I said we need to run two commands. So we ran Prisma deploy. It gave us our endpoint, and it took our note type and our data model and created a bunch of fields for it. And the last thing we need, as I said earlier, is we need this generated file. So I'm going to run Prisma generate, and we'll see what that does for us. Okay, so running Prisma generate, you'll see that now we have a generated folder, and let's explore what's in here. Okay, so this is a TypeScript file. We're not using TypeScript, so it doesn't matter. This file is not, you don't have to touch this as well. The real important file is this schema file right here. So it looks kind of scary. I was pretty scared. It has like a lot of stuff in here. They give you stuff out of the box for like filtering and pagination and so like a whole bunch of stuff. But we only care about we want to query for all our notes, and we want to be able to like make or update notes. So like queries and mutations. So just by telling Prisma what a note looks like, it was able to generate this entire file. And the reason for that is because this is a typed language, so it knows exactly what to expect given the same inputs. So using this file in a second, we'll be able to create notes, update notes, and delete notes a lot easier by using Prisma. All right, so now that we have this file, we need to have access to it, right? So I said that we're going to use this file for our resolvers, but how are my resolvers going to know about this file? And that's where this second package comes into play, the Prisma client library. So this is going to allow us to attach this file to every one of our resolvers, and we'll talk about that in a second. So I'm going to say const Prisma equals require, and I'm just going to point this to that generated file that we have. And this is another concept. So in addition to our type definitions and our resolvers, we can pass in a context object. And what a context object is, it's just a plain JavaScript object that every resolver can read and write to. So in a second, when we write our resolver functions, we'll be able to access everything in this file by doing context.prisma. So let's attach that here. Okay. And now let's actually let's build out our note-taking schema and whatnot, and we'll go over some more things there. So as I said earlier, if I have a list of notes, I want to be able to read those notes in some way, right? So I'm going to have to query for those notes, as we saw earlier. So my query has one root field of notes. And remember earlier, so we had info resolved to a string. Well, in addition to resolving to like the built-in types, you can resolve to other types. So I could say, hey, if I query for notes, I want you to return me notes. And so this will give us a singular note, but if I wrap this in array brackets, it'll tell me that, hey, I'm expecting an array of notes. And with the exclamation point, we can say, hey, if I query for this field, you will always have to return me an array of notes. Okay? And then we'll have a mutation type because we need a way to create notes, and mutations are all about modifying data. So we have a create note field. And to create a note, we're gonna need to supply some things, right? Because if you see our model right here, a note's expecting to have a title and a content. So when we create these notes, we're gonna need to supply those as arguments. So I'm gonna have title. So I'm gonna give this resolver a title, and that's gonna be a string. And then content, which is also a string. So I'm telling my server, if I write a mutation for a create note and I give you a title and a content, I'm expecting you to give me out a note. Okay? So I have my query for all of my notes, and I have a mutation written to create notes. There's one more thing we need to do in this file, and then we can implement our resolvers. And that is define this note type. So right now, I have this note defined in multiple places, but this file has no idea what a note looks like. Like, what are the fields? Are they required? And whatnot. And there's ways where you can just import these types into your schema file. But a lot of times you'll avoid that. We won't get into reasons. Like if you have users, you might not want to have the password exposed. But for this example, we're just going to redefine the type so that our server knows what to expect here. So again, we'll have an ID, title, and content. Okay, so now our GraphQL server knows what a note looks like. And as I said earlier, when updating your API, you'll have a field and then a corresponding resolver that fetches the data for that specific field. So I need to write one resolver for my notes field, and I need to write one resolver for my create note field. So we're going to write these resolvers, and then we're going to start our server and make sure everything's wired up correctly. So let's go into our resolvers file. We'll start with query. It's fairly simple. So remember, on our query, we have one field, which is notes, and that's defined again right here. We have one. If we had more fields, we would have to write more resolvers. So on my notes query, remember, your resolver is just a function that returns data. And here's the last core concept we'll talk about, and it's the arguments to this function. So there's only two that we have to be concerned with, but I'll just explain them all just so you have the reference. So arguments are exactly what they sound like. So when we make our create note, the arguments will be these fields. That's pretty self-explanatory. You work with arguments all the time. Context, this is that object I was talking about earlier. So a context, as I said, is an object that every resolver can write to and read from. And we made that possible right here. We put on our server a context object, and we attach this huge file to it. So that's going to allow us to do things with this file. And then parent. So parent is the result of the previous resolver execution level. Don't worry about that, but I'll just explain it again. So for example, if I had like nested fields here that went all the way to this level, let's just say there is more data available. The fields here will have access to the data that was returned up here. Again, just explaining that just so you don't see this and not understand it, but it's not important for our talk here. Last one is info. This is like rarely ever used. You'll probably never have to use it. It's basically just like a tree representation of your query. And again, it's like for very rare use cases, so I wouldn't worry too much about that. But anyways, let's first export this, just might as well. And let's write our resolver, which is a function that returns the data for our fields. So here, I'm going to return context.prisma. And again, this is possible because I attached the Prisma instance to my context object. And what do I want here? Well, let's look at that big generated file. So if I go to my query, we'll see that if I query for notes, I'm going to get an array of notes. So I can simply do, and this is one of my favorite parts about working with Prisma, I can simply say, hey, give me all of the notes and invoke that, and that's all we need to do here. So this is our resolver for all of our notes. Again, we went over these 4 arguments, and we returned context.prisma because we attached it to our instance, and then we asked for all of the notes, and that's possible because of our Prisma schema file. So I simply ask for all the notes, and Prisma will take care of all of the underlying like database operations for us. Okay, so I've implemented this resolver, and now we need to implement this create note resolver. So let me save this file, and then let's go into our mutation file. So const mutation, and I have one field, which is create note, and then this has parent args context info. Okay, so let's see what Prisma is expecting from us when we want to create a note. So I'll go back to my schema. Let's go back to that mutation. Okay, so if I want to create a note, I need to provide a note create input, and Prisma says, hey, if you do this for me, I'll give you a note. So let's see what this looks like. And if I look at this, it's simply title and content. And that's, again, because we told Prisma what our note should look like. So it's saying, hey, if you give me these fields, I will do all the underlying operations and give you a note. And we have those fields because in our schema, we're passing them in as arguments. So let's go back to mutation. So I'm going to say return context.prisma.create note, and not to just supply those arguments. So here I can do something like, okay, title equals args.title, and same thing for content. Or if you're familiar with ES6 syntax, I can just spread in all of my arguments. And that's the same thing as writing it out manually. It's just a bit more concise. And then let's export this file. Okay. So we'll start the server and make sure everything's working. Talk a little bit more about how it's working, implement, update, delete, and then we'll do a long recap explaining everything again in detail. So let me go back to my index file. So I've told my server where to get the types. It's in that schema file. The last thing, though, is that this resolver is just currently empty. But we took care of that here by exporting these resolvers. So we just need to import it into our file. So let's do that quickly. Okay, and then one for mutation. So let's just duplicate that. And then pass those along to our resolver. Okay, and if everything worked correctly, we should be able to run our server again. So let me just go back to it. Okay, so I'm gonna run this index file and pray for no errors. Okay, so everything looks like it's working. So let's, I can just refresh this tab, but I'll just open up a new GraphQL playground. And let's see what we're working with now. So let me get rid of this. And let's go over to our schema tab and see what API operations we have available to us. So if you see now, it's updated with our new fields that were defined in that schema.graphql file. We have a note type, so we know exactly what a note looks like. We have a create note mutation, and we know what we need to supply for it, what it outputs. And we have a query for notes that will give us an array of notes. So let's go ahead and write a query. So we're going to query for all of our notes. And as I said earlier, so before we had that info in the beginning, and it returned us a string, right? But here we're returning a note, and a note has its own fields. So I'm just going to say which one of those fields that I want. So, and here's another great thing about the GraphQL playground. It has autocomplete for us because everything is typed. So by typing control spacebar, it tells me all the available fields to me and what those types are. So here I'm gonna ask for the title and the content of all of my notes. So now I'm gonna run this query, and we're gonna expect an empty array. And that's just because we haven't actually created any notes. So let's go ahead and do that. I'll actually just add another tab. And so now if we want to create data, we need a mutation. So I'm gonna say mutation, create note, and right away it's gonna be yelling at me because again, it's strongly typed. So it has a strict structure saying, hey, you have to give me these certain arguments and you need to return some data. So for title, let's just, I don't know why this is, anyways. Okay, for title, we'll just call it note. And content, we'll just say note content. And to ensure that's working, let's just return the title and the content. Press play, and it worked. So it returned to us a note with the exact fields that we asked for. And going back to asking for only what you need, I can add ID to this query, and it'll show you the globally generated ID that we have. And if for some reason I don't need the content anymore, I can simply remove it from my query, and the data won't be returned for that field. So yeah, the typed language, this playground, like all these moving pieces, it's a lot, but once you get used to it, it really makes your developer experience a lot better. And as a quick side note, like there's a lot of new concepts being introduced now, but I think this talk is more of a way to get interested in GraphQL and then take your learning from there. So let's finish building out our update and delete functionality. So if I want to add new fields, there's two things I need to do. In my schema, I need to define what update and delete look like, and then I need to implement the resolvers for them. So let's go ahead and do that. So we'll say update note. And okay, if I want to update a note, I need to have the updated fields, right? But I also need to provide an ID because GraphQL needs, or my database needs to know which note it needs to update. So the ID is a unique way to identify that. So we're going to give it an ID, and then a title and content. And you'll see the only difference here is that these fields are no longer required, because what if I just want to update the title to my note and not the content? So that's why these are not required. And this is going to resolve to a note. And we'll just add delete right now because it's fairly simple. I just need to tell it, hey, okay, this is the ID of the note I want you to delete. Okay. So I've added two new fields to my mutation type, and now I just need to implement the resolvers, and that is how I add something to my schema. Okay, so let's go back to our resolvers file. And in addition to create note, we're gonna have to write one for update note and delete note. So let's start with update note. So I get parent, args, context, info. And again, let's go to that generated file to see what it expects us to give them in Prisma. So we'll go back to mutation. And let's go to the root definition. Okay, so if I want to update a note, I need to provide two things. So I need to provide data. So let's see what kind of data they want. So it looks like they want title and content again. So the only difference here is, remember, it's not required because I might only update one of these fields or none of these fields, okay? And it also needs a where field. And this, again, is just a unique identifier. So Prisma knows which ID it's looking for, okay? So if I give my update note mutation a data with the updates and then a where field telling it which ID, it's gonna provide an updated note for me, okay? So in my resolver, I need to get, a copy of our updates, and then pass updates plus unique identifier to Prisma, okay? So to get a copy of our updates, we'll just create a variable called updates, and we'll spread in all of our arguments. And our arguments, again, are ID, title, and content. But we don't need the ID field for this updates, right? We're only updating either the title or the content. So we can simply delete updates.id. So these are our updates. And now we need to pass the data and the unique identifier to Prisma. Okay, so we return context.prisma.update note. And for the data, we'll pass it the updates. And as far as where we want to update this, it will just be the ID that we pass in. So we'll pass in an object with the ID equals to args.id. So to recap, we got a copy of our updates. took off the ID field because we did not need it. And then we passed to Prisma our updated data, as well as which ID we need to update. And then we'll quickly do delete note because it's a lot simpler. So for delete note, I just need to give it a ID so it knows which ones to delete. To delete. So I can say return context.prisma.delete note. And I can say like where ID equals args.id, or I could just deconstruct my ID up here and pass that along. And with this, we have full CRUD functionality. Let's make sure it works, and then we'll do a recap. So I'm gonna go back and restart my server. Let's see, okay, looks like it's working. Open up a new playground. We'll look at our schema again, and we'll see that we now have these updated and deleted fields available to us. And it tells us exactly what to provide and what to expect. So we're gonna need an ID to delete. So let's make sure we have a query for an ID so I can pull that off. Okay, so let's work with this first one. So I just open up a new tab, and I'll show you a bit more of this autocomplete. So control spacebar tells me exactly what's available to me. And I want to update a note. And to update a note, I need to provide an ID of the note. So that's what I pulled off. And we'll just update the title to say updated. And we'll leave the content alone. To make sure that this is working, let's return that title. Okay, so I have an update note mutation. I passed it the ID as well as the updated fields. If I play this, we'll see that I get the updated data, and that should be reflected in our query. You'll see that this one has an updated title field. Okay, and the last one we'll do is delete. So we'll delete this updated note. So we'll take this ID, and let's write a mutation. And we'll write a delete note mutation and pass in that ID so it knows which notes to delete. And we'll return title again just to make sure that we deleted the right note. Okay, and to make sure that that's reflected, we can delete it. And we'll see that it no longer exists. And back to this hosted server, you'll see now that we have some data in here. So we have the two notes that we have. And there's a whole bunch of cool things you can do here, which is another great reason to use Prisma. Okay, so with that, we have built the full CRUD functionality for a note-taking API. Let's do a recap, and then if there's any questions, we can handle those. So in our index.js file, we brought in an instance of GraphQL server from GraphQL Yoga, and that's what we're using to build our GraphQL server. There's other implementations, but again, GraphQL Yoga is an easy start, and it's also really nice to use. Here, we're taking a Prisma instance, and this just points to our generated file that we have. And to make this work, we just had to install this Prisma client lib file. Okay. Here, we're just bringing in our resolvers that tell our server how to return the data for the fields. Here is just some notes. So here is our resolvers object, passing in those resolvers that we defined up here. And then the last part of this file is this server. So we created a new instance of our GraphQL server from GraphQL Yoga. We passed our type definitions, and that just points to our schema file that has all of our available API operations. Our resolvers, which we defined up here. And lastly, we attached Prisma to our context. And again, context is a plain JavaScript object that every resolver can read and write to. Okay, so after we configured our index file, we went ahead and got Prisma configured. And to work with Prisma, you need two things. You need a YML file, and this is just a configuration file that's kind of like a template for your Prisma API. We started off with an empty endpoint, but once we deployed, it gave us a hosted server. We pointed our data model file so it knew what to generate, and then we told Prisma where to generate that file. In our data model, all we have is our note type because we need a way to be able to take notes, obviously, in this application. And we just said, hey, we want a unique ID, a title, and a content. And then in our terminal, we ran Prisma deploy. It gave us some options, which we went through. It gave us an endpoint to our server, and it created all the necessary stuff for our type. Then we ran Prisma generate. That gave us this generated folder, and this gave us a bunch of API operations built out for us. And then once we had Prisma configured, we're ready to start building out our schema. So in our schema, we defined one query, which is, again, reading data. So if I had users, I can query for all the users. If I had anything, addresses, it's really up to your project. We have one field on our query of notes, and that returns an array of notes, which is required. And then we have a mutation type, which is anytime we're modifying, updating, deleting data. And we have three fields: create, update, delete, with the necessary arguments, and it returns a note. Lastly, we defined what a note looks like so that this file knows what to expect from a note. Once we have all of our fields defined, we needed to implement the corresponding resolvers, because once again, every field in your GraphQL schema is backed by a resolver. So we go into our resolvers folder. We have one field, notes. So to resolve that, we followed what was a guideline in this Prisma file, and we just returned all of our notes. Pretty simple here. In our mutation file, to create a note, we just have to supply the title and the content. So we pass them in as arguments. To update a note, we had to get a copy of our updates, delete the ID field because that is not an updatable field. And then we told Prisma what our updates are, as well as which note to update with this where field. And then lastly, for our delete operation, we had to tell Prisma which note to delete by providing an ID. Okay, so that's everything I have prepared. Thank you for coming on your lunch hour. If you have any questions or would like any resources, I'd be happy to help. I showed this earlier, this howtographql.com website. This is what I kind of started with, and I found it really helpful. So if anyone is interested in learning more about GraphQL, I highly recommend going through this. You can build out like sample applications similar to what we did. And it also has like front-end implementations, which we didn't get to today. So yeah, that's all I have today. And once again, thank you.
Awesome, thank you. I don't know if you want to bring up Slack, and we have a couple of questions in there.
Okay. It's in the brown bag channel, right?
Yep, brown bag channel on the questions thread.
Okay, can we link those articles? Okay, yeah, I'll pass all that along in a second. I have, how would you implement foreign keys to tie tables together? Also, I don't see routes, so can you still use fetch or Axios to do HTTP actions, or are you limited to Prisma on the front end? Yeah, so I would love to like build out the front end too, but that would take more time. But to answer your question, Prisma has nothing to do with your front end. It's just for building out your back end. As far as for foreign keys, I'm assuming you're thinking of like relationships between your data. So let me just actually share real quick. So Prisma has a way of doing that without getting too much into it. You can kind of just define it in your schema. So like if I had a user type, I can say that like this user has all of the notes that they themselves created, as well as like a name. So like if you look at the docs, Prisma has a way to do like the data modeling with like different keys and stuff like that. But that's a bit more advanced, so I didn't cover that here. But yeah, there's a way to do that with Prisma. And then I think there was one more part of that question. How would you, I don't see routes. So again, so one thing I didn't mention is GraphQL as compared to Rust is just a single endpoint. So when you're implementing on the front end, you can do routing in any library you want. So you can use like Next.js, you can use React Router. All GraphQL and Prisma are doing is providing the data. So you fetch the data on the front end and then route however you see fit. Prisma has nothing to do with that. Have you played around with stuff like GraphQL Express where you aren't using something like Prisma? Yeah, so I was thinking about, so yeah, I haven't been learning this for very long, but I've learned the fundamentals well enough to give a talk like this. I'm planning on like learning more about using like Apollo server and stuff instead of Prisma. I personally have been sticking to the Prisma stuff because one, in the howtographql.com website it was used. So I figured if they're recommending it, then it must be like a good way to approach it. I also took Wes Foster's Advanced React and GraphQL course, which uses Prisma. So it seems like to me that like Prisma is a popular option. That's one. I like using it, and I wanted to get really good with one tool before branching off. But yeah, I'll probably look into using something like that soon. Have you made a project that required you to pay for Prisma Cloud? So I have one production app with Prisma and stuff, but the free they have a free tier, and that works well for my use case. I'm not expecting a lot of traffic. It's more of like a portfolio piece. So yeah, the free tier should work well in most instances, unless you're expecting it to get like a lot of traffic. Do you know what database the demo servers are running in the background? I think it's like a MySQL database. Yeah, it is a MySQL database. And again, Prisma like does a bunch of stuff under the hood. That's why in our resolver we're able to just write like return Prisma.notes, and it takes care of all like the underlying stuff. So yeah, it uses MySQL underneath. But they're like Prisma supports pretty much everything. And if they're not supporting it, then they're working on it now. And you can see that on their website. So yeah, that's everything here. I guess we can wait like a couple minutes to see if anyone has any more questions. Yeah, I think that went pretty well. I thought I was gonna run into some errors or something, but I didn't have any errors.
I mean, live coding is scary as it is, but
Yeah, I just, like for preparation, I built this from scratch like 3 times in a row. And like if I really like do it fast, I can do the whole thing in like 10 minutes. So I did that like twice, and then after doing that, I'm like, all right, I know the syntax, I have it down, like because I know like errors make it more difficult to understand what's going on. So I really wanted to make sure that like I was comfortable with stuff. And then I kind of just like went in my head over like my talking points, like what I wanted to explain, and that's kind of like how I did this. Um, oh yeah, so let me pass those links, and then while I'm doing that, if there's no more questions, I guess we can end it there.
yeah,
So
so all the links you drop into the brown bag, I'll also add that to the Google Doc. So any students who are watching this in the future, you can hit up the Google Doc for additional information.
okay,
Looks like we are all wrapped up on questions, and I want to be mindful of everyone's time. So we are just going to go ahead and wrap it up. Thanks so much, Michael, for coming and,
thank you
teaching
so
everyone.
much for allowing me to do this. Yeah, I had a lot of fun with it, and yeah, I think it went pretty well. So yeah, in the future, like if there's something else I feel really comfortable with, I'd love to do this again.
Yeah, that would be great. We love having students, learn and then turn around and teach, help solidify the learning. So I'm going to go ahead and close this out. Everybody have a good day. Bye.
Thank you.